Well, we've already hit the 2 minute mark. Um, so I think maybe it'll just be us today, but we're recording this so people can watch it on their own time as well. So I'll go ahead and get started. Um, Welcome to Office Hours. Today I wanted to talk a little bit about Triton CNS. Brian gracefully did a presentation on it that I screwed up and didn't record properly. So maybe we'll have to try to somehow do that one again or something. But Triton CNS, I used it for a few things here and there. But after the presentation and then reading some of the documentation, I was like, this thing is really cool because it just has some cool features that I really like, and some things that when I was starting, we actually got a ticket from a customer about a problem with HAProxy. And so I started digging into like HAProxy, just fiddling with it myself. And I found these like things. I was like, whoa, this could work. This is cool. And then Triton CNS, I was like, okay, let's use Triton CNS with this HAProxy um, configuration. And that was cool. And then Nick from MNX suggested, hey, what about the SRV records? And I didn't even know how that Triton Triton CNS supported that. So then I was like, okay, that's cool too. And then Brian, of course, helped me do the SRV records. So I'll go ahead and let me get my presentation up here. We'll go through that really quick. Share your screen. Okay, and let me know if you guys see that. You see the slide there?
I see it.
Okay. So I just titled this Magic, even though it's really not magic. But so, like I said, we've talked about Triton CNS. Triton CNS makes it easy to use consistent and predictable addresses for all Triton compute instances. Um, Triton CNS serves address records for containers by instance name and tags. Nothing that new or crazy. Multiple containers providing the same service can share the same tag and will be returned to the same address. Same service, sorry, can share the same tag and will be returned to the same address record. We're going to be utilizing that today. It's really cool. And because Triton CNS knows when containers are started or stopped, um, including unexpected stops, the DNS information is automatically updated, um, and requests are automatically sent to running containers. So that's a kind of a built-in little health check feature there, which I think is really cool. I just got to resize this for the recording, so I'll have to edit this out. But anyways, um, so yeah, so that's some cool things there. Triton CNS is designed to do two things very well: serve address records for instances by name, instance name, so that's the individual record, and serve address record for instances grouped by service label tag. So multiple instances can be listed in one DNS name depending on their availability. And then, so I have an example down here in the MNX cloud. We have two types of records you can use with Triton CNS when you provision an instance and Triton CNS is enabled in your account. One will be .triton.zone, and then you'll see the pattern down there, the instance name, your account UID, data center name, Triton.zone. That's going to resolve the public IP address of your instance. And then if you have services tagged to that particular instance, or instances, I should say, you're going to have the same pattern, but with service name to the public IP address Triton.zone. And then for the example I'm going to be doing today, we're going to be using both. Um, so you have the instance name for that CNX.MNX layout. That will resolve the private IP address. So in this case, the Fabric network. So because I think by default in MNX Cloud, it's the public network and a Fabric network is what we have. And so in this case, I'm going to be using the Fabric network, so the .cns.mnx.io pattern for HAProxy to grab the private IP address, so that routing between the internal instances is going to be done over the Fabric network, and then the public IP. I think I'm just using an A record. I'll have to double check on my domain. So I'm using my own public domain, robbycloud.com, that I have to set this up. I think I have it set up as a C name for a front end service, but I may have changed that or something. But we can look at that later. But anyways, that's the pattern there. Really cool, really awesome. It makes things very, very cool and very easy. So yeah, that's the pattern for that. Go to the next slide here. So Triton CNS can be used to load balance. Every instance that shares the same tag is addressable using the same domain name. So if you have something like a front end service name, right, you can tag a bunch of instances running HAProxy something else, right? You can tag it front end. The only thing is with that, you're kind of at the mercy of DNS, right? You're at the mercy of TTL. You're at the mercy of the resolvers. And so it may not, it's not going to happen exactly in the way you might predict or want. So that's just one thing to note there. But it is possible to use it in that fashion. But like I said, resolving TTLs, DNS can be sometimes unpredictable. But it makes discovery of the instances easy, and the domain name's not going to change. So using it, putting it as the CNAME record, you're going to be able to use that every time you tag an instance. It's not going to change, so it's predictable. And then Triton CNS is designed to support global DNS services with DNS TTL times that work well for discovery on the larger internet. So all of these records that are added, if you're using the dig command, nslookup, if you're looking at, I use 8.8.8 Google's DNS because my domain that I'm using happens to be a Google domain and using their DNS, so it works well. The times update quickly. But you'll be able to go to any public DNS service and find the .triton.zone and the .cns.mnx.io records will resolve from any global resolver. And then what's really cool, and Nick, you pointed this out, welcome Nick, Triton CNS also supports the SRV records. So we can use discovery of the port protocol. There's also wait and priority in SRV records. And so I was doing this example and he pointed that out. So I actually modified this to use the SRV records. So it's actually going to discover the port as well, which is really cool. So if you have, your backend web service, in this case I'm using Node.js, running at a random port on your server, and I shouldn't say random, but you're having it on a port, other than 80 or something like that, you can spin up instances and run this application on this port you've designed. You tag it using the SRV record, and I'll show a little bit of how that's done, but you can have the protocol actually discovered too. So this will come into play in the HAProxy config, which I'm not going to go too much into, but I'm going to show you a few things there that are really cool, but it lets you discover the port, so that is really cool. And then the wait and the priority, when you have multiple instances in a record, in an SRV record, the wait and the priority come into play, and I don't fully understand it, so I'm not going to go too deep into that, but there's a way you can, like when they share the same priority, I think wait will design like how much traffic goes to one or the other based on the service. And so that depends on what you're using against the SRV record, but that's a cool thing about using this SRV record is there's some other things you can do besides just having it resolved to DNS, right? You can add some things on there. And so
Yeah, you can do that for if you want to do like A/B testing or something like that, or you want to have make sure that 10% of your traffic goes to the subset of instances that has like the new feature enabled or something like that.
yes, yeah, and that's where it's the same priority,
Yeah,
right? And
yeah.
then different weight. Is that the case, right?
Um, I like weight and priority are kind of like up to what's consuming it.
Okay.
So I'm not entirely sure how HAProxy uses it in this case, but those are like two levers to um, to adjust the balance of traffic across all of your instances.
Yeah.
So you can do things like A/B testing or enable on a subset of instances, um, or like if you have different hardware profiles, you can be like, all right, the instance that's on this server, um, that server has a newer processor, and so it can handle more traffic, and so we'll weight that one higher so that it gets more traffic, stuff like that.
Yeah.
Um,
And specifically in HAProxy, I will say that in the config, there's like you can specify different types of uh, load balancing, right? So there's like balance, least connection, round robin. So I think the configuration might over, go over what the SRV records. You might have to do like one certain configuration to like have the SRV records work a certain way. So like you said, it depends on what's consuming it. So there's because SRV records are used for things like like the examples they always give are like Jabber, XMPP, right? Um, so I'm in HAProxy it might work a little bit differently because you may have some other configs that may take priority over the SRV records, but it's still a cool way to use it, and I'll show that. And then so what I mentioned earlier was it may not be likely acceptable for connections between components within a data center. DNS TTL times might not be respected. And so this is where using something like HAProxy comes into play because we can actually do health checks and things like that that will be not irrespective of the TTL connection, right? So we can take things out of health if it's not responding for a set amount of time versus just respecting the DNS TTL. And then we can utilize things such as SSL termination. So in this case, I'm using Let's Encrypt to uh, have HTTPS SSL connection for my domain on HAProxy, and it serves up my node backends, and I don't have to even fiddle with Let's Encrypt on those backends. It's just all in HAProxy, really easy. And so that's going to give us the power of Triton CNS and that ease of that, and we're going to still be able to utilize SSL termination. And I haven't done like any HAProxy clustering. I'm not even sure if the free one has that feature. I'd have to look into it. I know it's on the enterprise one at least, but you can do that with the Triton CNS, like a front end service, right? You can have multiple HAProxy instances, but it will take some configuration. And so then I did want to talk about a little bit about HAProxy because that's part of this. So free, very fast, reliable reverse proxy offering high availability load balancing, hence its name. Particularly suited for high traffic websites and powers a significant portion of the world's most visited sites. Reddit, I think maybe even GitHub uses it. Um, and it has an enterprise edition for those needing support. So it's not only just an open source product, but it's an open source product with support. So similar to what we have, where we have a software product, and for those needing an enterprise level grade of support, it has that. So it's definitely a well supported product, and I like the way the configuration is done because it's kind of easy to read. And so HAProxy supports discovery by IP address and DNS, including custom resolvers. So and you can use things like console to do that, and then Triton CNS from a global DNS. And so in this case, I am actually using just the 8.8. I can actually configure it to use an internal resolver if I needed to. But since Triton CNS is globally available, I don't have to do anything special. And like I said earlier, it supports SSL termination, so it allows you to use certs such as Let's Encrypt with your custom domain and serve your application backend. So all you do is you do, um, in this case, I used the Acme cert script, just typed in my domain, and then there was a script that I double checked to make sure it was good, and it copies the certs into the HAProxy folder, and so there's like really easy process to get SSL running for your custom domain. So um, really simple to do. So and there's lots of guides and documentation out there, which is another cool thing about using HAProxy is that a lot of people are using it. So there's probably if you're looking to do something, somebody may have already written something up on it. So no need to reinvent the wheel. And then HAProxy configs allow for many different configurations, and we're going to discuss a couple items on there, which is server template, which we're utilizing, and sticky sessions. So, Brian, you had mentioned, how do you do sticky sessions? Well, there's actually a couple different ways, and I'll talk a little bit about them. But um, there's a cookie based one, so like it'll actually put a cookie onto the browser so that it will HAProxy will look for that and it will send you to the same backend repeatedly. So if you're doing something like a session, a login, something, it will make sure it keeps you with the same backend, right? And then there's also a table, a stick table, what they call, and you can do some different times and timeouts on that, which will actually track you in memory, the instance's memory by IP address, and map you to an instance. Um, and that can get, that can take up some memory. So it's not, I don't know how much it's utilized, but there's a couple different ways to achieve the backend because it actually, I was trying to work, when I was configuring this, I was doing it and I was like, I had it on round robin, and in my app, I have it so it shows the IP address so I can tell if I'm at a different server. I was like, why does it keep sending me to the same backend? It's supposed to be round robin. I had some configuration directives in there for sticky sessions. So after I commented those out, it started working. But I actually want to use that because it's actually a neat feature. And then I'll just talk a little bit about the Node.js app. I'm just using Express to make a few routes. I'm running it on port 3000 on two backend instances for this example. Uses a cookie for a user session in the app, but it can be shared between instances. The way I've made this application is that it can read the cookie and it can recognize it because I'm using the same key for this cookie in the Express app. So even if you get to a different instance, it will still know that you're logged into this particular session. And we'll be using HAProxy, serve to the HAProxy front end over the Fabric Network private IP. So this, all the communication between HAProxy and the node instances is going to be done over the Fabric network. So it's going to be using the internal .cns.mnx.io CNS name. So, okay, so next up, I've made a sacrifice of one Satoshi to the demo gods for good luck. So I'm going to actually switch here. So give me 1 second. Share my screen. If you have any questions, you can ask them as well. But let me figure out the screen sharing here. Okay. Just take me 1 second here because share your screen.
I thought you might have disappeared. It said stream has ended, but I
Yeah,
realized you're just getting stuff switched around.
yeah. I'm just double checking which screen to, because I have like my giant monitor here, so I'm just making sure. Okay, you're just gonna see a Google window for a second, but close that out here actually. Okay, so let me just make sure. I got to make sure OBS is on the right thing there. Okay, sorry for the delay. Okay, so all right, so you should be able to just. I have VS Code open here, so this is just the um, HA proxy config. Um, so I'm just gonna, and if you can't see it, I'll make it a little bit bigger. But let me take the terminal away here for a second. Um, so I actually have this example in GitHub as well. So I kind of scripted everything up to just make it easy for myself. But in the example, like I have it, so you could put your own domain in and all this. But first, I'll just show off what I did to for Triton CNS. So um, View Explorer. I'll take this away. Hold on. There we go. So in this case, I provisioned 3 instances, and I'm not going to suffer the pain of provisioning them. I've already done that, of course. But here's the tags I use. So I just did front end HAProxy for this one for the front end, um, and then I'll use that against the DNS for that. And then for the back end instances, I'm using this pattern here, which is the name of the service dot TCP, so the protocol, and then the port that it runs on, and then I gave it a priority, and they both have the same priority. Um, and this is going to give it an SRV record. So Brian actually showed me this. There's a little bit in the GitHub of Triton CNS. I think we need to. This is something we should add to the normal documentation. I don't think it's in there. So this is something we could definitely add is the SRV record pattern, and more info about that. Like I said, it's in the GitHub, but I'd like to add to the main documentation. But basically, this is going to give this tag, um, to give it this back end service tag in an SRV record. And so I've already provisioned these instances. In this case, I'm using an LX instance with the newest image available on MNX Cloud of Ubuntu 22, and then these are all the smallest instances because I don't need anything bigger. They're only running one process. So, um, anyways, so I've already got that up and running. So I'm just going to show you the HAProxy config really quick that I have running. So um, a lot of these are just some default options that I copied from a couple different examples that I saw. Like these are like standard ones that people are using. Um, so these are some defaults. In here, I've added the public IP address of the instance. You can use an asterisk to bind it to any IP, um, but it didn't work correctly for me the last few times, so I've explicitly put the IP address in here. So after I provisioned the instance, I had to go and get the IP, but that's not hard to do. Um, I'm using my robbycloud.com for this example, so I've already copied and downloaded the certs and copied them into the folder. So when we go to this website, it will terminate with SSL. Um, and then the resolvers. So I'm using just 8.8, which is Google's public DNS. But this allows you to use down here in this backend configuration. So these are where you do all the options for where HAProxy is going to reach out to the backend services. And down here, usually I'm using this server template. So normally in this configuration, you'd put server and you would actually list out your servers by IP address, right? So, but what if you wanted to automatically add things? And that's where this server template, which is a configuration thing that I found that was really cool, is that so you can actually name or sorry, number how many services or instances you might expect to have. So in this case, I just did 3. Right now, we only have 2 running, but I'll show you in this health check that it's going to be looking for 3. So whenever this third instance comes up to this DNS record, it will automatically, when it finds the correct health check and everything, it's going to automatically add it to the pool of available servers. So that's just a really cool feature of HAProxy. The only thing I don't like is like the number that you have to put in because you kind of have to have an expectation of how many you're going to have. I wish it would have like something where you could just not even specify the number and it would just grab it by how many you would add to the DNS record. Like if it sees 3, then okay, it likes 3. If you have 2, whatever. But that's something that maybe there might be a feature or something out there that do that. Um, and then in here I have the stats and stats URI. So this enables you to actually go onto the URL that you have and log in and see the servers and how HAProxy is running and what's happening in the back end here with a visual um, checkup. So that's what this is right here. So that's pretty cool. And then I have this. It's just a HTTP authentication change me. So it's not really a big deal because I have nothing secure running on there, and most of the time it's not actually running except for this example. And then you have to have for Let's Encrypt. It has this running localhost to help with the SSL termination. And then I did talk about a little bit about sticky sessions. So um, I have it running with a cookie, which I can show as well. But you have a key that this case, I'm just using it says my cookie, but um, you can put any type of key in here or how whatever you want to do. So this will actually make it so sessions will stick to a certain backend for a user when they encounter the front end. That user will be sent to the same backend for a while, even though I have it on balance round robin. So if those things weren't here, if these were commented out and this stick table IP was commented out, you would see when you refresh, you would get a different IP um, every time that you would refresh. Um, so anyways, now I'm going to go ahead. So I'll show you here this right here, backend TPC or TCP service. That's this internal IP address, right? So we're going to go ahead and we're going to show off. I'm just going to go to robbycloud.com where I have it running, and we're going to go to the health page. Oops, that's not right, actually. Sorry, stats. Okay, so this is the HAProxy health page, and you can see right here I have SSL running because I have the padlock up here, so you can look at the certificate, but you don't need to look at that. But anyways, it has Let's Encrypt running, and so this just shows you the health of the processes that you're running for HAProxy, and so which is divided up by how you name it in the config file. And www backend, like I showed in the config file, this is our backend servers. So there's two um, instances that are under that SRV record. And so backend one, backend two, it knows that they're there because of the SRV record. And it knows it's looking for a third one, but there's not a third one to find in that. So it tells you right here resolution. There's no DNS resolution for that third instance until I would add one. So that's that server template. So it knows that there's two instances running. They have a layer 7 health check. So they actually, I'll go back really quick to the config and just show you. They have a health check where they actually go to the instance and they look at the URL /health, and then they need to see in the return, they need to see the string success. So if it doesn't get that, it will not mark it healthy. Since the node process is not running on those two instances right now, it's not gonna be healthy. So what I'm gonna do, I'm gonna go ahead and I'm gonna SSH into those instances really quick. And I like how Triton has using the name. You don't have to remember IP addresses. You can use the short name. So I already have it running here, so I'm just going to say node app.js, server running at port 3000, running at port 3000. So we'll go back here, and we're just going to refresh, and so it checks it very quickly. So see how quickly it brought those up. It's already seeing the health check and seeing that success there. So now, and you can do this on your own browser if you want to, you go to robbycloud.com, and there's a login page. So then I can go in there, and the username is just Robbie. Password is Robbie because I fancy myself apparently. And there we go. It says, "Hey there, welcome," and it clicks to log out. That destroys the cookie. But I have in the code, I have it go and find the fabric IP address, and the way I did the command, it spits out the subnet as well. But I can tell exactly which server that I'm on because it tells me right here. So even if I refresh, because we have the sessions set, it's going to continue no matter if I refresh and I go back to the home page here. It's just going to take me to the same backend over and over. But I'll show the round robin here in just a second. So that's the sticky sessions, and I wanted to show that because I think, Brian, you were asking about that, and it's actually configurable in a multitude of ways. So it is possible to do that. But I'm going to continue to hit that same server. So we'll look over here, and it's only sending it to one server. You see, there's 0 bytes in and out from the other server because of that sticky sessions. So, so I can actually, I'm going to change that really quick. So, oops. So I'm just going to go, and yes, I'm a noob. I use Nano instead of Vim. So what I'm going to do is I am going to comment out um, I'm going to comment out the stick table and the cookie dynamic cookie options really quick, and then we're just going to restart the service here. Okay, it's still running, and then now we're going to do that same thing. We're just going to go here, and I'm actually going to go to the health check page, and you can see. I don't know if you guys can see. Is it clear here? But I'll make it bigger. But now when I refresh, it's now doing a round robin balance, right? So you see the IP address changing to the different backend there. So, so yeah, this is just HAProxy is just magic to me because it works so well. Um, and obviously, there's other things to consider when you're talking about load balancing. Like there's um, things with different types of connections, different types of health checks, and all of that. But this basic configuration using Triton CNS is just so easy and so cool because it takes a piece of it out of it that you don't have to go and manually go and change all the time. You don't have to worry about IP addresses. That part is taken care of for you. Um, and so yeah, it's just really cool how it's able to do that. And I can actually I want to, but I'm not going to. I want to spin up that third instance, but I don't want to make you guys suffer through the installation of all the software. But you can easily go and do a third instance and add another record there, and it will just automatically pop up here in the stats page. So let me just go back here. And now you'll see that traffic, because I have it on the round robin, it's being split between the two instances. So you'll see here there's traffic going to both instances. And of course, if you're on you could easily go to this robbycloud.com and look at it really quick before I take it down. Um, but yeah, this is just I thought was really awesome use of Triton CNS using the SRV records. It's on GitHub, so you can look at it what I've done. Um, there'll be this recorded video, of course, of our office hours, and I have another video that I'm gonna publish too of just a little bit going through this process. So, and if you have questions or things like that, you can ask them on Discord, ask them here, um, or in other channels or things like that, or put comments in the GitHub or anything. But yeah, I thought this was a really cool use of Triton CNS, and I think somebody mentioned um, a couple people mentioned that they're using HAProxy, and so it's very widely in use. And so I thought this would be cool to discuss. Does anybody have any questions? Let me
Well, let me just make a shameless plug for
get.
uh, for the Envoy port I'm maintaining,
Yes.
which basically does the same thing as
Yes.
HAProxy, but in a different way. I guess the main selling point of Envoy is the API, the gRPC API, which allows you to basically configure all the aspects of Envoy, which can be useful. It can also be a bit daunting. So um, it has its uses. I think there is also some JProxy is obviously fine, but there's some stuff which is in the open core and which is in the enterprise version and not in the open core. I think that's especially related to auth. Um, so when you use something like a HE proxy for your front end, for your ingress, it can be nice to you also use it as a zero trust solution. So you might want to do some OAuth or stuff like that. And I think that's in the enterprise version for HAProxy, if I'm not mistaken, and which is in which with Envoy is just freely available because it does not have an enterprise version. But then again, I also didn't think you can get any enterprise support on that. So just wanted to put it out there.
Yeah, and I mean that's a good point. That there's more than one um, available front end. So HAProxy, Envoy, Nginx, Apache. You can use CNS with those as well. So there's other front ends. I just used HAProxy as an example because I happened to dig into it. I haven't looked into Envoy until I think yesterday when you had mentioned it. So, but this is possible with other applications, and so I'm sure Envoy has maybe some options that HAProxy may stick to the enterprise. So that's something to check out. So I'll mention that as well, and that's what Triton CNS. It's kind of agnostic in that you know regard, in that it's for any service, and it doesn't have to be HAProxy. I just happen to use this on the example because I found this server template, and I was like, this is really cool. But Envoy, I'm sure, has something that um, may work just as well or better depending on your use case.
Yeah, CNS is really great at that. Might be worth mentioning that we also use it for PostgreSQL. So maybe if you have a big cluster, then you probably use something like PG Bouncer or something. But we have a relatively small cluster of just 3 nodes. So we just offload all the responsibility of finding the active node to the client. JDBC is the JDBC driver is actually pretty good at that. So we just pass it. All the CNS entries in it, which we dynamically generate via Terraform, because I don't think it can handle the SRV record. That would be really cool, but I don't think the JDBC driver can do that. But you can even use it for services like those.
Yeah, anything that will look things up by name and uh, use any of the IP addresses returned work.
Yeah, so that's really great because if you obviously if you start searching, you will probably run into something like etcd or console, which are fine solutions, but they're pretty big solutions, right? It's like running a Zookeeper cluster or running a console cluster is not without um, is not effortless, so to say. And CNS is something, well, if you're in Triton anyway, it's something you get for free.
Yeah,
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 and inevitably, when discussing something like this, somebody will bring up. I can imagine these comments coming in on the video once it's posted. Um, if you can already do round robin load balancing just through the DNS records, why complicate it with something like HAProxy or Envoy or whatever on the front end? Like, aren't you just moving that point of failure out one hop and making things more complicated? Um, there's actually a very good reason to have a dedicated load balancer in front. Um, and that's basically the health check. HAProxy, like as Robbie showed, does health check, and it can be much more responsive to loss of nodes or backend instances than CNS will be. Within Triton, a compute node goes down. It takes some amount of time for the CNS system to notice that, and then it publishes a new DNS record to match whatever the current state is, and then that TTL has to timeout for whatever else has been querying those names. And in kind of extreme circumstances, that could be like maybe 2-3 minutes um, before something drops out. All the while you're having connection errors, and frustrated users. But with HAProxy, having those active health checks, if a node misses a health check, it'll drop it out immediately. So it can be much more responsive based on the real time behavior of whatever's on the back end. Um, and you can set things in variable ways, like uh, you know, you don't have to look only for an error condition being returned. Like you can set the timeout for an instance for you know um, like whatever length of time you want to be able to withstand. So like in the case where like one compute node gets slammed for whatever reason, um, and it's completely overloaded, that one is slow on the health checks. HAProxy or whatever could drop that one out and shift load to other instances until that one is more responsive, um, which is something that CNS itself can't do on its own. Um, Another advantage of this is um, being able to dynamically shift around the back end and keeping the front end on a stable set of IPs, um, which helps with DNS caching down the line, um, and it gives you less variability on your front end, so that you can do things like application upgrades and stuff, which are probably much more likely to occur on your node application than it is on HAProxy itself. So those are some of the benefits of having a dedicated load balancer layer rather than just using the CNS round robin directly to provide a service.
Yeah, and that's what I was kind of
Brian, you
stressing. Oh,
mentioned
sorry.
health checks,
Mhm.
and I remember you showed us a method in the past of from the compute node itself removing itself from the service record.
Yes,
Is that
I have.
generally the,
Um, Let me find the repo for it.
basically just allowing a maintenance mode to be enabled, from the command line on a node that you might be taking out of service or something like that to do something?
Yeah. So yeah, what it is basically it's a system for a node to health check itself, um, and um, if it detects that itself is unhealthy, then it'll put CNS status down, which will pull it out of the name. Um, and I think I have that in one of my personal repos.
But
Yeah,
essentially,
Triton
there's
CNS Health.
a meta or M data tag, right? That takes it in and out of CNS. Is that
Mm-hmm.
yeah? Okay.
Yeah, I'm gonna drop this repo into the chat here.
Yeah, because that's similar to
Um,
the instance one then, like because you can do M data inside the instance to take it out of CNS as well.
right.
So that's very similar to that if it's for the
Mm-hmm.
compute node.
Yeah.
Yeah, that's great.
And it's pretty handy. And it's a really like lightweight wrapper. You basically drop shell scripts into the checkd directory, and it'll run those once per minute. And if it exits um, an error condition, then it'll set Triton CNS status down. Um, so yeah, I like using both of those actually, like that and the HAProxy health check.
Yeah, and that was the main reason. Like I was like, okay, this how this it talks about like the internal why it's CNS might not be perfect for the internal resolution. The things with DNS, but that health checking that you can customize, like you said with HAProxy in this case, it was just after I was reading, I was like, that's so easy to do. Like
Yeah,
in this case, it was like, okay, I even set a URL so it has to find. Now you can do it even way more simple than I did. You could just say give an HTTP 200. You can do a TCP health check. In this case, I did a layer 7, so it just actually goes to the URL and looks for the string success. So it's got a couple of conditions it has to do. It has to have a 200, so it has to reach it. The URL has to resolve, and it has to be with the 200, and it has to have the string success. So you can really
yeah,
customize your health checks, which is cool. I mean, like you said, Triton CNS, it gives you all those features besides that, right? So it gives you all this stuff because DNS only can do so much, but it does a lot.
right.
It does a lot. So
Yeah, and it's the delay in realizing that there's an error condition until the behavior of the application is like surfaced to end users.
Yeah.
Doing just DNS records, in a good scenario, you're probably waiting more than a minute um, for that to transpire. And having the active health checks can pull that out a lot easier.
Yeah, and that's why I say like you're kind of at the mercy of DNS because one of the things is you can't control how the client resolves, right, or how a client caches
Right.
things, or
Yeah.
do they respect the TTL, right? Um, because
Yeah.
and because everybody's going to be using different uh, public or whatever, they're going to be using different DNS resolvers. Like a lot of home users, um, like for instance, even on my like home router, my DNS resolver it actually goes to 192.168.0.1. It goes to um my router, which obviously it gets it from my internet service, which in this case is T-Mobile. I don't even know what they use, but um unless I go in and manually change it to Google DNS or Cloudflare or something, right? I'm using a service, something that's probably doesn't really respect TTLs that much, and so sometimes you're at the mercy. The client is using something that caches, or depending on your browser, will cache things just to not do an extra DNS lookup. So sometimes
Yeah.
the client's at
And
a mercy of that.
for each layer of cache that you have in there, um, you know, conceivably, every single thing picked up its message at the very last second of the last TTL thing, right? Um, so um, if you have, four layers of caching going on, even with a 30-second TTL,
Mm-hmm.
your worst case scenario there is you've got a 2-minute delay from changes into reality to that fourth layer of the cache. Um,
Exactly. Yeah, in TTLs in 30, it's weird because I think 30-second TTLs, which does Triton CNS use those by default?
mhm.
Okay, so
Yeah, and it's not configurable. I mean,
okay,
if you're running your own Triton, you could go change the code. But aside from that, it's going to be 30 seconds.
okay, great. I mean, that's
That's
good.
about like kind of the sweet spot between responsiveness and uh, not making changes too quickly with things. Um, so yeah, but with DNS because it's um, uh, cached data, um, it's about the best that we can do. Um, but that's why we also use things like HAProxy on top of that, so that we can be more responsive to changes on the back end.
Yeah, and I only mentioned the 30 seconds only because um, so for and I experienced this when a previous place that I worked with we did hotel websites at this startup that I was at years ago, and so I encountered every domain provider, every DNS provider that I could think of because I was doing so many website launches and I had to deal with all sorts of different providers. And going through those, I learned so much about DNS and domains and like certain providers you wouldn't support this type of record, or they only let you like they didn't support 30-second TTLs, right? Like there's limits out there to what you can do for your domain depending on your provider. Like I said, for my RobbieCloud.com that I bought a long time ago, I'm using Google DNS, or Google's the domain registrar, which Squarespace purchased, but I'm using Google's DNS. It's really nice because it supports every type of record and supports 30-second TTLs. And I think that's probably the same with Cloudflare. Cloudflare, I'm sure, they've probably got a pretty robust system. But sometimes people may be using a domain provider or don't have custom DNS for their domain, and they don't have those options, so they do have longer TTLs. Um, Now, if they're a bigger application, they should be using something that has more features, hopefully, and gives them more control. But I'm just saying, just some people just don't know. Like they could be doing their application just don't know that their DNS provider doesn't give them all the options they need. So the caching, the TTL thing is huge, like I said, because sometimes you can't even set 30 seconds, so you may be having long cache times, and so you may see extended hits at a service that's out because just because the client's still trying to go to an IP address that's not working. I think that's where we talk about, I think elastic IP, right, is something that people ask about because I think that's one thing that takes, it takes DNS out of it a little bit. But that actually has to have, of course, a bunch of stuff behind it to work, right? Like elastic IP, there's a bunch of instances and logic behind doing elastic IP. But I think Triton CNS, personally, I like this method versus elastic IP um,
Mhm.
because elastic IP you have to set that A record, right? And so you
Right.
can't use multiple IP address. Like it actually kind of introduces in a way a little bit of a single point of failure because what if there's a problem with the logic behind elastic IP, right? So
Yeah, you can only put that IP onto a single instance. You can't have it on multiple instances.
yeah,
Um, but yeah, whenever someone brings up Elastic IP, I like to think of CNS as like Elastic Name Service, you
yes,
know, because it pretty much gives you the same thing just with a name instead of an IP. Um, you can do a vanity C name to your backend name, or you could do a vanity A record to that IP, right? Um, there's not really a lot of use cases where um, what you actually need is a specific static IP
yeah,
address that's going to float around. 99% of cases, um, a static name that can float around will satisfy that requirement just as well.
yeah, exactly. And I was just because I was looking at that chart we have on the documentation page, and just looking at the differences from the different features, and I was like, because what I was trying to find out was does does Route 53 have something comparable to Triton CNS? And I think what I found, I'd have to dig into it more. I did a little bit of looking into it, but like, I think you can do, I think what I just saw was like user data scripts. Like you would do something like, it's like you would use the AWS API and you use a user data script and it will add like records to Route 53 when like you provision the instance, but it's nowhere near as elegant as Triton CNS is. Like Triton CNS, I was like,
Right. And that's not
yeah,
automatic. That's,
exactly. That's work you have to do. Yeah.
you have to, right. You have to do it manually.
Yes.
Whereas with CNS, as long as it's enabled in the cloud, it's just there automatically on and you get it for free.
Yes. So, like I said, I was just trying to find the comparable thing just so I could have an understanding. I was like, do they have something like that? They may, I don't know, but Amazon separates out their services, right? So, EC2 is separate from Route 53 because you could not even use, you know, anything else in AWS. You could use just Route 53, right? We could like you could use Triton and use Route 53 for your DNS just because you want to, right? Because Route 53 is actually a pretty good DNS service, and I think it's had like 100% uptime or something because it's distributed. So, I mean, it may be tightly integrated with EC2 in some ways, but I didn't see something as cool as Triton CNS and as useful and as easy and automatic. Just the way I just think the way that it's designed, the way it works, it's so cool. It fascinates me because I was like, it just works. And like I said, that server template really really got me into building this because I was like, okay, now you can utilize Triton CNS. Now there one thing I will say, it doesn't have auto scaling, right? So we don't have something like auto scale in this little configuration I've made, but there's ways to
Right.
maybe do
Which
that.
that's something that um, uh, interacts more with the orchestration system
Yes.
than it does with just like health checks and load balancing,
Yeah.
you know. But you could like kind of, you'd have to build the stuff yourself, but we have CMON metrics available, right? You could have something that is watching your key performance indicator metric, and when something drops below a certain threshold, spawn more instances. Um, the parts for doing that are there and available.
Hmm.
It's just not something that is like directly built into Triton. Um, so like um, uh, I'm not sure how far we, as someone who is like selling you instances, should go to, oh, we're just going to automatically provision instances
Yeah.
that make us money without asking you about it. You
Yeah.
know what I mean?
Yeah. Yeah. And then Jasper said, does maybe the Triton Nomad driver do that? Did you mean? Okay, go ahead.
I really haven't used Nomad very much. But I know that like um Terraform, you can say like I want this number of instances to be available, and it'll make sure that that number of instances is available, so that like if one of them vanishes for whatever reason, it can create more. Um, and Docker Compose can do that, and you can point Docker Compose directly at Triton, and that works. Um,
Yeah, I can't.
so
Yeah, and I
yeah,
can't say like, oh, I've like I just mentioned the auto scaling because it was in the documentation page, and like I think it's a feature people you know talk about. I'm not sure. I couldn't say how widely used it is specifically, like or you know, like I maybe I'd have to look. Yeah,
yeah.
there you go.
In
Feature
my
people think
experience,
they want.
it's talked about way more than it's used.
Yeah,
Um, like the vast majority of services um, don't need reactive auto scaling. Um, you set your three instances because you want to have a minimum redundancy level, not because a single instance couldn't handle that load. You know what I mean?
yeah,
Um, unless you're getting up into the range where you are Facebook, Amazon, Apple, Google, Uber, some, those insanely popular apps that like um, everybody's using, and there's probably minimum of tens to hundreds of instances
yeah,
backing those services at any one time. Um, unless you're that scale, um, you probably really don't need automatic reactive auto scaling.
yeah.
So
And that's like you said. That's where CMON also comes into play, right? Is that um you can look at your key performance metrics on CMON, look at loads over time and things like that, and kind of make decisions based on those
right,
as well, right? Like, okay, we're actually, or that also will maybe tuning your application too. Like, there may be things you can do in other areas rather than just horizontally scaling. Like, maybe you need to fix something in your application, things like that.
yeah, and like you know, it's good to keep an eye on those metrics and know like when you need to scale up or down. Um, but it's unlikely that most applications have the kind of variability in their load profile that would warrant reactive auto scaling, you know? Because like if you're running three instances and your application gets popular, it starts growing, um, you're going to spill over into four instances, six instances, whatever, after like X amount of time. Um, unless it was like you got slash dotted, which I don't even know if people use that term anymore. Um, or if slash dot could even cause that effect these days. Um, but unless it's something like that where it's just like a very unexpected extreme spike in traffic that goes away in a few hours and then never happens again. Um, Probably your application is not going to need um, variability in load.
Yeah.
You grow to a certain point, and then you're bigger, and that you're always that size now because that's the number of customers that you have, and that's like the general load profile that you have.
Yeah.
It's it's very unlikely that you're going to have where you need 8 instances during the day and only 2 instances at night, or um, you need like 36 instances during the summer months, but uh, once November rolls around, then you're going to need to double that, and the last week of November you need to double that again. Um, Very few applications need that kind of variability. Um, and even if you did, like, if my application went 10x during the month of November, um, I'm not entirely sure I'd want to just like ignore it and let the software handle that because it's not something that like happens frequently enough that I would be 100% certain that it was always going to work. Because like, let's say it worked one year, and then that traffic load goes away at the end of December, right? And then you have another 10 months where you're making changes of all kinds to the system,
Yeah.
and then like, okay, next November, like, are you sure that none of the changes that you made are going to interfere with your ability of growing 100x when you need to? That's the kind of thing like I would rather have an operations team like on it and have like pre-spun up the capacity and made sure that it's like tested and is going to work um, uh, before that happens, because part of reactive autoscaling is ensuring that applications will deploy flawlessly, non-interactively every time. And a lot of times that's harder than it seems like it should be.
Yeah, and you're also talking about, is your application, like we said, the different metrics, like, okay, this time, the database is overloaded, or um, the front end is overloaded, right? I guess that's where the metrics would come into play, and you would design it around that. But you know, is your data, like, if you're using like a SQL database, like, you actually probably need to vertically scale up, right? So it's going to depend on your architecture totally on when to do that.
Right.
So it's a question that gets asked, but it's really a more complicated, like, yes or no, right? There's always these like, well, okay, well, you need to do this or this, because we talked about it a lot when because a Steel app, Brocade, the VTMs had a feature like that. But we would always ask, like,
Yeah.
where are you dependent on your application? Are you CPU dependent? Are you RAM dependent? Like, okay, maybe you need to think about, are you provisioning enough RAM for your instances then, or you know, yeah, it just really depends on, like, is your application even horizontally scalable at this time? Like, did you design it in such a way? So
Yeah.
there's other
And
questions.
for all of the discussion that goes on around reactive autoscaling, um, uh, there's like a vanishingly narrow use case where that's actually the correct solution, um, as opposed to something else that is less automatic but more deterministic, and provably correct, you know?
And funny enough, Triton CNS can fit into all those use cases, I think, because of the
Right.
fact that you can use it in such a way that it'll be, when you're adding instances and doing health checks, Triton CNS can be at the heart of that and can work in the way you want by either using it just as it is, or in this case, like we talked about, the HAProxy or another application, Envoy or front end or even back end things where you can resolve, but you have extra health checks or extra layers to know when to take instances in or out of service. And so once again, Triton CNS, that's why I love how it works, because it's like, okay, well, it can, oh, you want to do this? Well, it can be at the heart of it. There's a way to fit it in, and it makes things easier. And so that's why I was like, okay, you did part one and just talked about it. Okay, this is a good, cool way to implement it. And that's why I wanted to show that off, because I'm like, this is just, it's just cool. I tell my wife, I'm like, this is really cool. She's like, I don't understand that. I'm like, I know it's kind of dumb, but it's really cool. Okay, we're a little bit over time. Sorry. But I wanted to thank you all for joining us. Is there any other questions or comments anybody has? Thank you.
I've said
Thanks for
my
putting that
seconds.
together. It was a great presentation. Thanks,
Yeah,
Robert.
yeah. Thank you. Thank you for mentioning the SRV record, because that was like, I did it and then I was like, okay, now I got to go try this out. It's just, and that's something I think we need to really add to the docs, because I think it's like in a little bit of the GitHub, but not all the way there. So like, I'll definitely get that. I'll get that added. I'll make a pull request for that, Brian. I don't know how to. I'll have to have you review it, because I don't know how to type it up, but I'll do something, because it's like, it just works and it's cool. So
Yeah, it's discussed in the CNS repo.
yeah,
In the operator guide section.
yeah, that's where I found something about it. But when I didn't know the
Yeah.
part about, like, because I got you, like you said, the underscore service. I thought from reading that it has to be that way, that it has to be the underscore service underscore TCP. But you can have SRV records that
Right.
don't actually have that exact naming.
Yeah,
So
the underscore name dot underscore TCP is really only supposed to be for well-known services.
right,
So like XMPP or LDAP. There's uh like a set of IANA like names that are like the official ones. So like if you're doing an official one, then like you definitely need to use those. Other than the official ones, it's okay to use any name. It doesn't have to follow that format.
yeah. So if you're running a Jabber service, XMPP, or if you're doing something else, an application that expects the name of the service to be that, then yes, you need to follow that, but you don't necessarily need to. I did for this example just because I could, but it doesn't necessarily have to be that way.
Right.
But thank you for showing me the way on that. Okay, I won't
Mhm.
keep you guys any longer, but thank you very much for joining. This will be uploaded, so the people who are watching this later, I hope you check this out and continue to use Triton CNS. It's very cool. So thank you, everybody. We'll see you on the next one.